Hello everyone, welcoming all of you in my organic chemistry class, and this class is very important for all those students who are in class 11, class 12, even in our own university, that is BBMK University. It is also applicable for the semester 3rd student. These are the basic concepts that all of you must need to understand. So let's start with the topic, finding hybridization of carbon atom in alkane, alkene and alkyne. So let us start with the topic, how to find out the hybridization. In organic chemistry, if you want to find out the hybridization, what you need to understand? You need to understand that there is a possibility of three types of hybrid orbital, which are sp, sp2 and sp3. If there are 4 sigma bond, then it will be sp3. In case of having 3 sigma bond, it will be sp2, and in case of having 2 sigma bond, then the hybrid orbital will be sp. And when it is sp, then it will also have 2 pi bond, and in case of sp2 there are 1 pi bond between the carbon atom and 1 sigma bond between the carbon atom. So let's start with the topic, फाइंडिंग हाइब्रिडाइजेशन बाय VVT. सबसे पहले क्या करना है, कार्बन का हाइब्रिडाइजेशन जब निकालेंगे, एल्केन, हमारा एल्केन यहाँ पर क्या है, CH4 है, तो जितना सराउंडिंग एटम होगा उसके वैलेंसी के इक्विवेलेंट अनपेयर्ड इलेक्ट्रॉन होना चाहिए. तो हम यहाँ पर कन्फिग्रेशन लिख लिए 1:2, 2:2, 2p2, और ग्राउंड स्टेट में हमने दिखाया वैलेंस शेल कन्फिग्रेशन को, 2s में 2 इलेक्ट्रॉन, 2p में 2 इलेक्ट्रॉन, जो कि देख सकते हैं, और अनपेयर्ड इलेक्ट्रॉन ग्राउंड स्टेट में 2 है. कार्बन 4 सिग्मा बॉन्ड बना रहा है, तो यहाँ पर 4 अनपेयर्ड इलेक्ट्रॉन होना चाहिए. तो यहाँ 2s से एक जंप कर रहा है, और ये अरेंजमेंट हमें देखने को मिलता है. तो हाइब्रिड ऑर्बिटल क्या हो गया, एस का 1 बॉक्स, पी का 3 बॉक्स, हाइब्रिड ऑर्बिटल आया sp3. और sp3 होने पर स्ट्रक्चर क्या होता है, टेट्राहेड्रल, जो यहाँ पर इस टेट्राहेड्रल स्ट्रक्चर को दिखाया गया है. थोड़ा एनलार्ज कर देते हैं. यू कैन सी द स्ट्रक्चर ऑफ मीथेन मॉलिक्यूल, and it has tetrahedral structure, 3-dimensional pattern. And how many bonds are there? There are 4 single covalent bond, and this is the bond angle, and the value of bond angle is 109.5 degrees. Suppose the hybridization is sp3, then the bond angle and all the bond pair electron, there is no unshared pair of electron, there are 4 bond pair electron, so the bond angle will be 109.5 degree. Move on to the next part. If we want to find out the hybridization of carbon atom in alkene molecule, then we have taken ethene to explain it. This is the structure of ethene, and now each carbon form 3 sigma bond and 1 pi bond, because the valency of carbon is 4, so the number of bonds will be 4. And in case of ethene, there are 3 sigma bond formed by each carbon atom and 1 pi bond. So you can write the hybrid orbital sp2, or each carbon atom hybrid orbital is sp2. But the number of electrons must be 4 because it is tetravalent. So again you can see the configuration is 1s2 2s2 2p2. The valence shell configuration represent the ground state, and in ground state 2s atomic orbital has 2 electron and 2p has 1 electron each, one in 2px and another one in 2py orbital. 2pz orbital is vacant. The number of bonds are 4, so there is a shifting of 1 electron from 2s to 2pz, and now you can see that the tetravalence is satisfied, but according to the structure it is sp2. So this atomic orbital 2p8 do not take part in the hybridization, and it will form pi bond bilateral overlapping. So let's see the example. Lateral overlapping. This is the actual structure. You can see here the carbon atom is sp2 hybrid orbital. So you can see the carbon atom is sp2 hybrid orbital for each carbon atom, and there is a overlapping between the hybrid orbital with the surrounding atom's atomic orbital, and it forms sigma bond. sp2 1s sigma bond, which are also known as terminal bond, and each carbon atom form 1 sigma and 1 pi bond within itself and form the sp2 sigma bond and 2pz pi bond. So this is the structure of alkene, and what is the example that we have taken? That is C2H4. Now the little bit something we can show here. Number of sigma bond. How many sigma bonds are there? There are 5 sigma bond, sp2 1s 4 and sp2 1. So the type of sigma bond of two type sp2 1s, which are 4 in number, and sp2 which is 1 in number, and number of pi bond is equal to 1. So in this way you can very easily find out the structure of alkyne also. Here you can see that we have already taken under consideration acetylene, triple bond between two carbon atom means 1 sigma and 2 phi. So here you can see that each carbon atom form 1 sigma bond with the terminal hydrogen and 1 sigma bond with itself, and forming sp hybrid orbital. So we'll discuss it in our next class. Till then, thank you and goodbye.